2014 from Anna University Chennai under the Faculty of Electrical Engineering. He has published two patents and more than 20 papers in reputed international journals with science citation and Scopus indices. He has guided more than 10 PhD scholars as external supervisor and has evaluated 25 PhD theses so far. He is a life member of ISTE, member of Institution of Engineers and Society for Automotive Engineers. He is the Kerala State Coordinator for Green 9 NSERV Club, an international club that strives hard to promote energy conservation activities among the public. Currently, he is working as Professor and Head Department of Electrical and Electronics Engineering, Ahalya School of Engineering and Technology, Palakkad. He is also the coordinator for the Ahalya Center for Energy and Environment. He provides consultancy services for various coir industries under Pollachi Coir Cluster. His areas of interest include special electrical machines, uh, Internet of Things, artificial intelligence, smart grids, and energy auditing and management. So, I welcome you, sir. You can start,
Thank
sir.
you, sir. Thank you. Thank you, Professor. First of all, very good morning to all the participants, organizers of RVS College of Engineering. I'm happy to associate with RVS College for this webinar on the title Green Mobility. Thank you, my dear fellow colleagues or ex-colleague, Professor Sundarprakash Balaji, for giving me the opportunity to present on the title Green Mobility. Thank you, sir. Thank you for your management also. Thank you, participants, for joining this webinar. So let me start the presentation. My topic of interest of today is green mobility. Hope you all know we should completely move towards electric vehicles. So that is the core idea behind green mobility. So what this presentation do, or what are the agenda of today's presentation? We are going to see the past trends, uncertain future, and need for modernized transportation systems. And main point of agenda, green mobility, which includes two important types of transportation system. One is electric vehicles and another one is hybrid electric vehicles. So in the technology of each and every part of this topic, I would like to cover to certain extents, maybe because the platform consists of a mixed group of audience. So pure electrical or the drives part will be eliminated, whereas more concern about the general phenomenon of transportation system will be dealt in this entire webinar. So introduction to the past trends and uncertain future. For the past 200 years, there has been a wide change in the transportation system on certain parameters based on the speed, capacity, geographical coverage, and efficiency. Say, for instance, I'm hailing from my hometown Pollachi, and Valpara is one of the we call it as Princess of Hills, Valpara. So it is almost 60 kilometers from Pollachi, where you have almost 40 hairpin bends. So during my younger days, I used to hear stories from my grandfather and grandmother that they used to have only bullock carts almost till 1970. So only till 1970, the transportation happened between Pollachi town and Valparai. Connectivity was happened only with the help of bullock carts. Right? In the year 1969, the first Alia Dam was inaugurated by our former Chief Minister, Dr. Kamrajaya. So on that day, from that day onwards, since the day on the day of inauguration, there was this facility available from Pollachi town to Alia. After that, once again the bullock carts are available. But now we can see quite a number of vehicles were flying from Pollachi to Valpara. Right? Even during this lockdown period also, 2 weeks back, one Sunday, one fine morning on Sunday, there was a very big problem with the help of particularly for the traffic police, because too many bike riders, particularly from Kerala state, without any e-pass, they enter into Tamil Nadu state, and they were trying to go to Chalakudi via Pollachi town and Valparai town, right? So almost some 20-30 vehicles have been seized by the people. So 30-40 years back, it was completely bullock carts, but now you can see two-wheelers, four-wheelers, everything. So this is what the rapid change that is happening in the transportation industry. Right? So that rapid change are on the four parameters. First one is the speed, next one is the capacity, geographical coverage. Yes. Why I'm meaning or citing this particular example of this Valparai town means that is the best example which covers everything, the speed aspects, the capacity aspects, geographical coverage, because it is not a plain terrain, it is a hilly terrain. So it has lots of ups and downs. And you people might be knowing what is the difficulty in driving in a hairpin bend, right? And also the most important parameter which is driving the entire transportation system is the efficiency, right? So within this 200 years, though we say 200 years, I personally have experienced with my age of 40 years, I have experienced a wide change in all these four parameters, right? Why these changes happen? The changes happen because of two important things, that is revolutionary changes, rapid revolution, or the incremental changes. Revolutionary changes means we have bullock carts and then we slowly moved into IC engine systems, steam engine systems, and then we moved into IC engine systems. Whereas incremental changes, a small change in the efficiency. Efficiency in this is the case of fuel efficiency, economic efficiency, cost efficiency, everything. So these changes are happening, and it is a continuous improvement are being happening in all these systems. Right? So the revolutionary changes, what these revolutionary changes are leading to? The revolutionary changes are leading to create new market and growth opportunities. Yes, previously people were thinking of how to go from one country to another country, but both the sea transportation system, sand transportation system via the water medium and the air medium has completely made everything into upside down, right? Previously, it took some months for us to travel from one country to another country, but within hardly 20 hours of time, we can go from one corner of the world to another corner of the world. So such changes are happening only because of the revolutionary changes, right? Then it aims with the substantial cost and capacity of time benefits. Yes, whatever the changes that happens in the world, they have to be considered at three main parameters. One is substantial cost. The cost should be affordable by even a small middle class family, right? Then the capacity. How much can be the capacity? Is there any changes in the capacity? Previously, we had only two fellow. That is when the Wright brothers found the aeroplane, invented the aeroplane. What happened is it is capable of having only two passengers, but now almost a Boeing 380 can have 320 passengers, and I think the maximum capacity of a passenger flight is almost 720, if I'm right. Right. So such changes are happening in the capacity, and also time benefits. Yes, time benefit is most important one. As said earlier, instead of taking months to go to travel from one continent to another continent, it's just hardly 20 hours is sufficient to flew from one corner of the world to another corner of the world. Right. So the potential of innovation can be exaggerated. Yes, we can exaggerate it at any means, but it purely depends on the investments on the technologies that limits the market potential and also the profitability. So all the revolutionary changes, what happens is they are aiming at substantial cost, capacity, and time benefits. Whereas coming to the incremental changes or evolutionary changes are happening only stepwise improvement. This stepwise improvement are relating with more capacity, productivity with more capacity, lower cost, and better performance. The simple example, let me say you, when Swift petrol engine was launched, I hope its mileage was only 14 kilometers, if I'm right. But now the improved version of Swift, and particularly Swift Desire, even automated system, AMT, Swift Desire, AMT, if I'm right, the conventional efficiency, the on-road efficiency, I would like to say, on-road fuel efficiency of Swift Desire. Even one of my relatives is owning it. So with this experience, I would like to say the automatic machine efficiency was almost 22 kilometers per liter. It is giving an efficiency of 22 kilometers per liter. See, what is the change? So the change started from 14 kilometers per liter. Within a hardly decade of years, it has reached 22 kilometers. So such development, stepwise development, improvement in each and every factor, the engineers work on it, on the design parameters, the challenging parameters, the weight parameters. They have considered everything. And also the safety parameters. Whenever we come across a transportation system, safety is one another important parameter which we have to look into, and it should be with an optimized cost. So having all these constraints and conditions, they have worked out and see they have improved the efficiency of the system from 14 kilometers per liter to 22 kilometers. Those say the condition supply, they say that in the brochure, they say it's 25 kilometers per liter, but on road, certain vehicles are giving even 22 to 23 kilometers at an optimal speed or the critical speed condition. So this is what incremental or evolutionary changes, right? So two main changes that happening in the industry. One is incremental changes, and another one is revolutionary changes. These two changes contributed for the wide variation of transportation system from bullock carts to rapid transportation system. This is what we are going to see, how the changes have happened, what are the impacts of the modern technologies on those changes that we are going to see in this class. How the future transportation system will be. It should integrate both the physical and information systems. Right? It should be faster, more efficient, and it should have linked the phases of economic development of the country, world economy. Yes. Last year, after the swan ceremony, our Prime Minister said that we will have a very high, fast bullet trains running between Ahmedabad and Delhi. So it is under that. That is what one of the economic development which is going to be linked, right? Which is contributing for the world economy and also Indian economy to a greater extent. So like that, the physical integration between the integration between the physical and information systems. Yes, in the further slides, you will see the best examples for each and everything. And this is what essential in the future transportation system. It should be a convenient, a compact system is required with more information, more sort of information, right? You can see in the previous ambassador cars, there was no, there will be only an analog fuel indicator, but now even in my car, I have a very good digital indicator, which will say what is the fuel capacity level, how many kilometers I can ride, and suppose if my fuel is coming to towards empty, it will start alarming me, passing on information me, making me alarm such that I have to go search the nearest fuel station and I have to fill it. So such information systems, that is physical and information connectivity. The fuel tank is a physical system. The information that is given by the fuel tank via the dashboard to the human interface, that is called the information system. So future transportation system seems to have such kind of good connectivity between both these environments, and it should be very fast and more efficient, right? So the system should not say after suppose if the fuel is going to get completely vanished, it should not say often indicate that deficiency in the fuel after getting it dry. It should priorly inform the driver, or it should priorly inform the person riding the vehicle, right? So it should be very fast and more efficient. Faster in the sense it should also cover limited a particular distance with a less period of time. So this is what expected from the future transportation system. So this future transportation system is completely going to be assisted with the help of automation and information technologies. In the 20th century, they introduced this is what introduced in the 20th century, that is high-speed train networks and freight systems. Whereas in the 21st century, we all know that it is only the dominance of IC engines. Rapid changes are happening in the IC engines, and it is depending on cars and trucks. And very important parameters looking for alternative fuels. So that is also one important feature. Then in the future, what we are going to do is we are going to integrate the entire information and communication technologies, what we call it as simply the terminology is defined by IoT, right? What this ICT, that is information and communication technologies, in terms of IoT or in terms of artificial intelligence or in terms of machine learning, what is going to happen is they are going to improve the speed, improve the efficiency, and very, very important one, improve the safety of the passengers. Right? Safety of the passengers, safety of the goods, and reliability of mobility. All these four parameters are going to be addressed with the help of automation and information technologies. So how this automation is going to happen? The automation will be assisted with the help of GPS, sensors, mobile communication technologies. Then it also improves the navigation and congestion mitigation by providing proper driving assistance, identifying the destination, fuel station, terminus, etc., guiding through traffic densities. I think the people attending this webinar would have come across all these systems, right? GPS. In the latest, recently I bought a vehicle, a four-wheeler, upgraded four-wheeler, which consists of a GPS tracker. So whenever an ignition, my car ignition is started, automatically a message will be coming to my mobile phone, right? So that is a best significance, so that I can see, suppose if any threat is happening to my vehicle, I can easily say, oh, who is starting the car, and I can come to know my vehicle is started. Not only that, how many times my vehicle is on and off in a period, that also I can get such an information, right? This is happening only because of GPS system, sensors, and mobile communication technologies, right? Then another one very good feature is driving assistance. Nowadays, all the cars are having Google Maps enabled with them. So driving assistance, if you want to go to a particular remote area, just you mark them. If the remote area is mapped with Google, the vehicle will be driving you, making you to go there, right? It will provide the complete driving assistance to you. Not only that, in that system, suppose if you are going and if you are not filled the tank properly, it will give you it will identify the nearest to fuel stations also, right? Fuel stations, the bus terminus, everything will also be identified with the help of automation systems, and guiding through traffic densities. Yes, what I heard is during this COVID period, too many people were trying to come out of Chennai city with the help of two-wheelers, right? So people going in one particular traffic congestion area, they will mark this area, this path is very, very highly traffic, right? So what happens is that information will be passed on to the other people, so the people can take a different path, right? So with the help of this type of automation technologies, people can easily find out the simplest way and make their life very, very sophisticated, right? This automation is going to boom with the help of IoT. Or IoT, we can say that IoT is going to be the boom of this automation systems, particularly in case of transportation engineering. So this IoT, the simple example definitions for IoT is, it is network of connected and identifiable devices. We can have n number of devices connected with them, connected in a network, and all these devices will be identifiable. You can either mask the device, masking also available, but each device will be identifiable with its own unique identity. Right? Then can be embedded with the transportation systems. This IoT effectively manages and guides the transportation system. The entire parameter IoT, and along with the smart grid, we call it as IoE, smart Internet of Energy system, which is going to play a vital role in the near future, particularly in the transportation system, that we will see in the forthcoming slides. And this IoT handles a large volume of data to predict the routing and demand forecasting. Right? 2 years back, I was going through one PhD thesis submitted to Anna University. So that thesis was saying about IoT device and the machine learning principle, which will be indicating some what to say, it will calculate the distance that will be covered by an electric vehicle, particularly for goods vehicle, how the battery should be charged, at what instance the battery should be charged, what is the load that will be carried by from each and every source to destination. All those parameters are taken into account, and the simplest route will be identified by this IoT based system, right? So this IoT based system, what they do is they use predictive analysis and the reports from the sensor, right? Predictive analysis means, suppose the a vehicle which is moving in front of the other vehicle has got a damaged, then that road is blocked, right? You can see when people moving from Satyamangalam to Bannari via the Dimmam, always there will be a quite large number of disturbances which can happen frequently. It is happening frequently, right? So because of any lorry breakdown or any truck breakdown, what happens is the entire system will get the transportation system will get stuck over there, right? So with the help of this predictive analysis and what is happening in the instant analysis and the report from the system, we can easily say, okay, instead of going via Dimam, we can take an alternate route, right? So such kind of informations will be provided by the Internet of Things, automation with the Internet of Things, right? So now, what sort of systems are expected in the future? In the future, we are expected to have all these kind of systems, which the primary one is going to be ODC, on-demand car service. But now this on-demand car service is available everywhere elsewhere. Then driverless cars, a good Google driverless cars has been experienced. Then subway transportation system, high-speed rail network. In India, very soon we are going to have the high-speed rail network. Then string theory transportation development system and flying taxis. Yes, Uber has got permission to get this flying taxis around the world, and particularly in Mumbai, they are planning for flying taxis. And last and most important one is alternate fuel systems. Balaji sir, 2 minutes, sir. My mobile is making some problem. I will catch you in 2 minutes, please. An audience, please text in the chat box whether it is informative. Whether the session is informative. I'm not going in depth of theoretical concepts. Can you please text it? Okay, thank you. Now let us see one by one what the each future transportation system is going to be. On-demand car service. So this is not that much future as of today. The reason is everybody has an app in your hand. You will have either Uber app or Ola app, and whenever it is required, you can just press it. You can say your source and you can say your destination. So immediately what happens is the nearest car which is available, that is we have a shortest routing algorithm and finding methods, robust algorithms to search which vehicle is available near without having passenger. They will be allocated, proper routing will be allocated to them, and information will be going to the driver. And once when the driver acknowledges your receipt of information, then immediately the information will be transferred to you people. Then you within certain period, including the time also, not only the time, where the vehicle is available, that location is also can be seen through the app. This is what we call it as on-demand car service. The best examples are Uber and Ola are the best one, and we have even in Coimbatore we have red taxi, call taxis. All those things are coming with more sophisticated on-demand car services. So this on-demand car service, actually it's a hybrid operational model. Actually it was a business model. It was developed by Ola Technologies, basically, and then upgraded with by Uber. It is a operational model between taxi and private vehicle. Right? Actually, it was a concept developed by two young students who were trying to rent their vehicle. Right? That is the basic phenomenon of how this ODCS came into existence. Right? So with this information technologies, the fleet cars can be managed, leased in real time, which results in less vehicle requirement to convey a similar level of mobility. Yes, then less parking space requirement. Each and everybody cannot afford for a good vehicle, and parking space is very, very high, particularly in metro cities. When you rent a home, they will be charging something for parking the vehicle also, right? Thank God such system is not penetrating deeper into urban cities. But metro everywhere it is there, right? Then improving congestion high density areas and increased productivity. These are the properties of ODCs, on demand car service. Then comes the driverless vehicles. These are driverless vehicles. You would have seen such kind of systems in either Facebooks or Hello apps or in all the social media networks, right? So here what we can do is, this is being tested by Google, and but Google failed literally, to be frank, right? So there are steps are being taken by the transportation regulatory authority people to make it completely check the validation of this driverless vehicles, right? So what you have to do is you have to just log in into the system. That means enter into the vehicle through your map. You don't even want to touch that vehicle, right? With the help of your mobile phone, you can make the vehicle to come near to you, stand in front of you, open the door. Everything is completely assisted with the help of your mobile phone, right? So only simply using the mobile phone, your mobile phone, you can enter into your vehicle, you can pick your source, you can pick your destination. So automatically what happens is that entire system, the automated system, the sensors, the complex algorithm systems, they will find a simplest or the shortest route, and they will make you to reach the destination in a very sophisticated manner. This is what the driverless systems do, right? So this driverless system is evolved with the integration of IoT. Without IoT, we cannot imagine a driverless system, right? Here, the main constraint is safety is the main constraint, right? Because it is a driverless, we are not going to drive it, right? So when appropriate, the brake has to be applied, when the acceleration has to be there, when deceleration has to be there, everything will be taken into account, and the system performs based on those constraints, right? So the basic one, safety is going to be 100% ensured with the help of driverless vehicles. And for your information, Google failed in this particular aspect at one point, but what is the advantage is it reduces the bottlenecks created by the driver behavior. Suppose if the driver is in a very nasty mood, he will have a rash driving, right? You could see warnings in many of the commercial vehicles and particularly vehicles, passenger vehicles carrying school children. There are some warnings. If this vehicle is found rash driving, please inform to so and so, right? So such things we are creating awareness to reduce the behavior or to make a good behavior of the driver, right? So such kind of bottlenecks can be removed when we go with the driverless vehicles. It limits the accidents, though it says it limits the accidents. Yes, there are possibilities to get accidents, but on an overall picture, when you look into it, reduces the accidents, right? Then employed initially as a remote controlled air cargo freights. It is already insisted. The simplest example, in certain films, you can see a drone carrying passenger goods from one area to another area. And recently, we are happy to see that our film star Ajit Kumar has developed a drone which has been used for spraying the sanitizers throughout Chennai city, right? He was behind that screen, and it is currently being used to operate ships. Tire-based vehicle ships are operated. The next part of the transportation system is subway transportation system. Subway transportation system is the basic transportation system is called as Hyperloop, and in future we are going to have this kind of subway transportation systems. So Hyperloop is the basic fundamental subway transportation system, which is using a combination of electric engine and mechanical engine, dubbed as a Hyperloop, right? So Hyperloop, it resembles a wagon train operating at a pressure of 100 pascals. It was developed by Elon Musk. Elon Musk is a pioneer in bringing any sort of changes in the modern transportation system. He was even called as the father of modern transportation system. This Hyperloop runs at 240 miles per hour, and it has a higher speeds. Higher speeds are also possible, right? Then developers hope to achieve 3 times speed. Yes, once when the finished subway transportation system of Hyperloop is going to be available, it will have be of almost 3 times, somewhere around 720 miles per hour. They are aimed. It is to cover a shorter distance in a short span, more distance in a short span of time. But there are certain drawbacks in the Hyperloop system because we need a high-speed rail, right? So the managing between the friction and air resistance is going to be a very tedious task, right? So to avoid this drawback of manage friction, air friction and air resistance, they are coming with the concept of magnetic levitation. The people from electrical background knowing about magnetic levitation motor principle, right, which allows a speed of 1,000 miles per hour. So this is the best example for magnetic levitation systems. It says that a train will be moving. It will be like just passing on. The train will be jumping from one point to another point. It will be moving rails, jumping over the rails. The magnetic system, largest commercial magnetic levitation system was opened in Shanghai in 2003. Operational about 4 meters, but it's only for a distance 30 kilometers, and it is quite unprofitable due to many parameters. The cost is the most important parameter. The cost of the system was very, very high. Now we have a high-speed rail built by South Korea and China. Their combination, the collaboration of South Korean transportation system, transportation department, and China transportation department come with a magnetic levitation train, which covers almost 350 meters in 40 minutes. Minutes to from Coimbatore to such a distance covered only in 40 minutes. But in normal, it takes 6 to hours to travel to, right? So such distance is covered in 40 minutes and helps in traffic-free congestion routes, right? It's airport and accidents, but main issue is cost of what is it? The main preliminary which is contributing for this high-speed rail network is go for additional infrastructure. The existing infrastructure may not be sufficient. In India, we have road facilities, but the railway facilities may not be sufficient. We have to additional huge investment. Right? So that is a main drawback of the high-speed rail network. Do this high directly to between destinations. So if, say, for example, if this magnetic levitation based high-speed is India, right, particularly in Tamil Nadu, we can go within an hour. We can move from Chennai. So hardly 1 hour. You can even name it is almost equal to the flight traveling time. Hardly 1 hour. So string theory is a thing that is behind this transportation development, which models the interaction between gravitation, electromagnetism, nuclear force, weak and nuclear force, and together combination. I'm going to cover in depth of the string theory. Simplest, how efficiently a vehicle can move from source to destination, covering a major distance with a short span of time, taking into account of the gravitational force, earth gravitational force, the electromagnetic effect of the working principle of that system, then the nuclear forces. Nuclear forces means the force exacting between, either it may be a central or centrifugal force, right? This is quite popular in physics. Constant based on things with the vehicle riding them. This is the first foremost principle when in order to have proper balancing between any system, we go with the two-wheelers, right? So two wheels stringed with a wheel in them, and it is a new low-cost transportation system. It can be used in water, deserts, or forest, right? Then another important one is flying taxis. Flying taxi, Uber is with such a system, and they have got permission to in Mumbai city. If there's not been by the end of the year 2020, they were trying to test this kind of transportation system in India. This flying technologies is a combination of Uber, Boeing, and Airbus. These three companies, they have joined together, and they have come across with this concept of flying taxis, right? So Uber plans to have this concept by 2023, but recently they changed their policy and trying to do it in 2020 itself. Right? So as per the agreement between the two, NASA and Uber, Uber will share its plan for implementing an urban aviation rideshare network, and NASA will use the latest in airspace management computer, modeling, simulation, everything. That is the complete, what to say, the license holder will be from Uber, but the design principles will be from NASA. right? So NASA will take care of completely the delivering the drones, the vehicle takeoff, landing capability, the capacity of that. Everything will be taken care by NASA engineers, and Uber will be holding its license. So such an agreement was made for flying taxis. So when flying taxis comes into existence, the transportation will be very, very simple. Then the last module of that transportation system is the alternate fuel cars, which is going to lead to the topic of the webinar, that is green mobility. Right? So the types of alternate fuels were basically the alternate fuels started with the water-fueled cars, which we call as hydrogen-enabled systems, and then we have electric cars, and recently in the market we do have hybrid vehicles. So what is a water-fueled car? This is what the internal structure of a water-fueled car. This is a 100% car with a 0% emission. Emission is no way it is going to contribute, right? So what is this emission? What is the percentage of this emission and all we will see in the later slides. So when you look into this picture says this is the complete membrane or the complete system. There is no IC engine at all. We have a electrolytic chamber where we will have an anode and a cathode. In between the anode and cathode, we have a membrane. So what we do is we pour water into it, so that water will be through hydrolysis or electrolysis process, it will be converted into oxygen and hydrogen separations will happen, and hydrogen will be stored in the tank, right? And there will be with the help of hydrogen, what we do is we generate electricity with the help of power electronic and electromagnetic system. So from basically the power will be driving batteries, the low power will be used to charge the batteries, and from the battery the entire driving system will be driven. This is what for water fueled car. So the source of this or the fuel for this water fueled car is it is water system, which splits into hydrogen and oxygen. So from hydrogen we are going to drive the battery, and the battery power is used to drive the engine. This is what the working principle of a water fueled car. Right? This water fuel car was invented by American Stanley Allen Meyer. He was a person behind this water fueled car. It drives energy directly from water. So the energy that is liberated by splitting the hydrogen and oxygen, that energy is used to drive the car. And the water is fully oxidized hydrogen. Hydrogen itself is a high energy flammable substance. That's why it is used in the process of heating also, right? So when useful energy is released when water is formed, and water will not bend, the process of electrolysis is the basic principle which is behind this water fueled car. But there are some drawbacks in the water fuel system. That is, energy would be lost in converting water to hydrogen and then burning the hydrogen. So we have something called as waste heat will be available. Then the releasing chemical energy from water will also be in equal portion, right? So nowadays we have a concept called as smart grid, where we use this waste heat into CHP systems. CHP systems are called as combined heat power systems, right? So the ultimate principle of this combined heat power systems are cogeneration systems, which electrical people may be knowing much about it, combined heat power and cogeneration systems. So a water fuel car is also converted into a combined heat power system, and sometimes can also be used for irrigation purpose, to pump the water from the well, and it can also irrigate a particular quantum of land, right? This is also being tried out in China recently. Then coming to the main topic, what is green mobility? What are the features, advantages we are going to it? So before going to green mobility in depth, we should know what are the challenges faced. The challenges faced in the conventional transportation system or the at present transportation system is road congestion. That is one thing. Then urban sprawl, quite everything is converted into rural villages are being converted into urban cities. Right? So when it took 10, 20 years back, Chennai city was limited with only 400 meters of radius. But now see what is the kilometer of span it has sprawled, right? Then air pollution. Air pollution is greenhouse gases and their transportation. The main important fact for the cost for greenhouse gases emission is transportation system, and it contributes around 24%. So the contribution of gases emitted by transportation system is 24% contributing for the greenhouse gas emission. So this is one survey, and the result of the survey which says that 75% of CO2 emissions are from urban cities. Right? That is, people living in the urban cities are contributing around 72 to 75% of liberating carbon dioxide emissions. This is happening only because of urban cities. Why? What's the reason? The reason is PCRI. We have a Petroleum Commercial Research Analysis Institute. What they say is, see, even if one people want to drive to a particular source to destination, people in urban cities are driving them. They are not using a public transportation system, or they are not using a shared transportation system. They always go and drive individually. So taking that into account only, they have come across with this 72% or 78% statistical data. So in this is a scenario of the United States, right, by the greenhouse gas emission sector. So this says that almost 28% of transportation system is contributing for the greenhouse gas emission, equally contributed by electricity. Right now, though we say electricity is generated by renewable energy resources, but the major contributor of energy is by natural gas, so which also has this greenhouse gas emission. So both transportation sector and electricity sector are contributing with a 28% of greenhouse gas emission in the United States. What is the solution? So taking these contributions into effect, the solution what we can do is reducing the emissions is going to be the need of the hour. Right? Very soon, or else what happens is our future generations will not have sufficient water, and the third world war is supposed to happen only because of pure air. Right? So pure air and cultivation of food items are going to be the major contributions for the third world war. So taking that into account, what they say is reducing the emissions is going to be the need of the hour. Who can contribute for this reducing the emissions? Green mobility, right? So this green mobility is going to be the main key sector for economic growth. Now, what are the questions arised when we go for green mobility? The first question is how we can be more efficient and identifying and implementing green mobility solution. What are the better means? What are the sources? How we can efficiently improve the green mobility system? That is the first question, right? Then how to contribute the achievement of sustainable development. When we say about green mobility contributes more for sustainable development. So what is going to be the impact of it? Then how this green mobility is going to affect the urban planning, right? Because our cities are not structured cities, are what to say, properly planned cities. Whereas when you go towards Chandigarh and all, everything is in a proper manner. The construction of the entire city is going to be in a proper manner, in a sector manner, or in a phased manner. Whereas in Tamil Nadu, in particularly when we speak about Coimbatore or in Chennai, they are not in properly planned systems, right? Nowadays, people are coming with the DDCP is coming with the more number of planned systems, taking all the things into effect, including water, drainage, then transportation, everything is, and electricity, everything they are considering it, and they are going for such a planned system, right? So these are the questions to be arised. So green mobility system or green mobility will answer for all these questions. The first one is we should know what is the definition for green mobility. Green mobility is sustainable transportation system that allows the basic needs of individuals and societies to met safely in a manner consistent with human ecosystem and with the equity within between generations, right? So green mobility is going to result in a sustainable transportation system, a transportation system which will be lasting for a good number of years, right? Which will be more sophisticated, which will be more comfortable, making the human life to be more comfortable and more sophisticated by properly providing a safety aspect in all constraints. Such a system is called as green mobility system, right? So this green mobility system activates the support for long-term livelihood of our society, right? It is going to support our livelihood for a long time. What a green mobility should be? It should be affordable even by the low class people, whoever it may be. operating efficiently. Yes, by consuming more fuel, it should not cover a shorter distance. So it should be very efficient. Then offering choice of transport mode, right? Any choice of transport mode. So for the another example for this choice of transport mode is Kerala state is one of the best example for it, because in Alapula and Kumarakom we have two means of transport. One is the waterways and also the roadways. The best example recently I personally experienced the example when I went to Chetla for a training program. I went to Vaikam, which is on the other bank of the river, right? So in between Chertala and Vaikam, there was a river flowing on, right? So there are two different modes of transportation systems from Chertala to Vaikam. One is via water means and another one is road means, right? So one day I went through road means, which took almost 1.5 hours for me to reach a distance of hardly 20 meters. It took 1.5 hours for me to reach there from Chertala to Vaikam. Whereas with the help of this water is hardly within 15 to 20 minutes, I crossed the entire river, and I went to the other bank of the river, which is the Vaikam city. So this complete choice of transportation system will be given, and this is contributed by green mobility system, right? And it supports a vibrant economy, right? See, traveling via a car for 1.5 hours will consume more fuel, whereas just if only for 15 to 20 minutes traveling by a ship or traveling by a boat will be more economy, right? So then limits emissions and waste. For 1.5 hours travel, the IC engines will contribute for more emissions and wastage, whereas but by the water medium, the emissions will be very less, right? Then minimizes consumption of non-renewable energy resources. Then reduces, reuses, recycle and its components. Yes, whenever we speak about renewable energy, reduce, reuse, and recycle are the three important phenomena behind them, and minimizing the use of land and the production of noise. Right? When you travel by a car, but nowadays all the modern transportation systems are coming with too much of noise as a suppression systems. But in earlier days, we had too much of noise production for it, but now it is reduced. Right? So these are the expectations from a green mobility system. A green mobility system or a green transportation system have four means. Basically, it is coming arising in four means. One is alternate fuel source. Second one is bicycle means. Third one is pedestrian means, and the final one is public transportation system. All these four type of systems contribute more for green mobility. Now let us see each and everything in detail. Right. So this is the best example of green mobility system. As I said earlier, green mobility ensures sustainable development and sustainable transportation system, and also contributes for safety of the human being. Right. So you could see large number of markings available. Say here it is a bus marking which says that only buses has to travel, and for pedestrians this is a path for the pedestrians, this is a path for the cyclist. So all these are ensuring safety. So such kind of system when developed, this is called also a green mobility system, right? Then this is another one system which shows the bridges for biking and walking. So this is a separate bridge that is built only for biking and walking people, only for pedestrians and biking in the sense two wheelers maybe starting from bicycles to the conventional to the latest two-wheelers, anything can be right only. This bridge is only constructed only for it. Then they reduce fuel consumption. That is, when you use bicycles, obviously they reduce fuel consumption. Not only that, sharing the sources also reduce the fuel consumption. Then comfortable biking. Biking is very comfortable. You can see people carrying the bicycles. They can flip their bicycles into small packages and pack it comfortably and can take it from one place to another place. They can even hang it at one particular point. All these are also the effects of green mobility, right? Then follow the rhythm of the street. Now, what is it? You can see there are two clocks over here. This is somewhere around 9 o'clock. So this is somewhere around some 3 or 4 o'clock. So you can see at this time only cyclists are allowed to go in this particular street, whereas during this particular time This is the path for the cyclists, and this is the path for the buses. That is shifting the what that transportation means that sharing the transportation means in a particular lane via different means of transportation. That is called as following the rhythm of the street. So this rhythm of the street is based on the traffic density, the population of people using it, then the time factor. All those parameters will be considered into the system, and according to that the system will say whether only people coming in bicycle or pedestrians has to come across, or two-wheelers will be allowed or four-wheelers will be allowed. Such decisions will be taken by the system, which we call as following the rhythm of the street. This also contributes for uh, green mobility. In the world, Germany is the first country to implement the green mobility principles, and Freiburg is the city which come out with green mobility or ensuring green mobility, that is sustainable transport. What they did is they replaced almost all the two-wheelers with the help of bicycles. Right, people were asked to use only bicycles and not to use bikes in some time factor. That is, they are not insisting to use only bicycles, but for a particular period, say for example, from morning 8 o'clock to 10 o'clock, people were asked to use only bicycles. Right. So they have an extensive tram network and provides priorities to the pedestrians. Except in India, wherever you go, particularly to any other well-developed countries, pedestrians are given most important or significance and priority. Right? Particularly, I have come across with my own example or my own experience. When my cousin visited Australia, he met an accident. Right? And what they say is he has hit on a pedestrian. So that becomes a very big issue. The reason is pedestrians are not making any harm to the society. Just by walking from one place to another place, they are making their life very, very healthy. They are making they are having a very, very safety life. But when you are riding a two-wheeler, that is a IC engine based two-wheeler or a four-wheeler or a six-wheeler, you are contributing major effect for the environmental pollution. So what they say is pedestrians are making the environment more sustainable, but the other people are polluting the environment. That's why pedestrians are given most priority in other rest part of the developed countries. But we are not in India. It is completely upside down, right? So this makes living without a car very easy, right? So this principle implemented in Germany made the life without a car very, very easy. People started using bicycles to travel from one point, even to from office to from home to office. They used to travel only with their bicycles, right? In India, yes, can we implement this green mobility in India? Yes, we can implement easily this green mobility in India, but there are certain needs that are to be implemented. First one is infrastructure for bus transport, depots, maintenance facilities, ITS, bus terminus, everything is required. That is information transporting system, everything is required. And even Tamil Nadu government has a proposal to have a well-connected IoT based transport bus depot. Busport, they are calling it as Busport in Salem, which is going to be the phenomenal one, pioneer one in India. Then it is going to contribute with the private entrepreneurial spirits in operation and promote non-motorized transports. That is last mile connectivity. Non-motorized means nothing with the help of IC engine combinations, and it is trying to promote alternate fuels and electric mobility for the environment, and it is focusing on urban freight and address high fatalities of pedestrians. But certainly this is not going to happen, or it will take some decade of years to happen in India, because changing the mind of Indians from moving from conventional or transportation system to be a pedestrian is very, very difficult. So the green mobility in India first experienced at Ahmedabad, Gujarat. They have a bus rapid transport transist in Ahmedabad, Gujarat, which you make use of completely electric vehicle transportation system, which reduces the pollution to a greater extent. Right? So this is what the electric bus transportation system that happened in Ahmedabad. What are the advantages of green mobility? It helps to ease the traffic congestion. Traffic congestion can be reduced, improves the air quality, and optimize the transport networks. It makes the transport network more efficient and environmental friendly. As CO2 emission is reduced, we can have a clean atmosphere, right? And it also contributes for less noise. Pollution is reduced, increased quality of life, and makes cities best place to live in, right? And make cities safer for pedestrians and cyclists. Not only that, coming to engineering point of view, it has great opportunities for electronics, booming of electronics industries. Because when we speak about electric vehicles, the quantum of electronics contribution towards electric vehicles is very, very high. Particularly, we can develop high power IGBTs, MOSFETs, memories, protection device, regulators, all those things can be a rapid increase in the production of these ICs can contribute for with the help of green mobility, right? Then passengers may can have affordable collective transportation and shared car. Shared car is the best phenomenon. Even Uber and Ola have shared car principle. Uh, two or three people, according to the capacity of the car or capacity of the transport system, they can share the rented car, right? And this makes people healthier. These are the main advantages of green mobility system. Whenever we speak about advantages, certainly there will be great disadvantages. The disadvantages coming to the type of the system available, electric vehicles are the major contributor green mobility system, right? So coming to the point, principle of electric vehicles, the main challenges are adoption of the electric vehicles. Conventional vehicle into electric vehicles is going to be a great headache. Then process involved and the price, cost of the price. Then inadequate charging infrastructure. India is lagging very much in this charging infrastructure, but there is a policy by the Indian government that is by the year by the year 2025, almost 75 percentage of conventional vehicles should be converted into electric vehicles. Indian government is working towards it, but we don't know how we will reach it, right? Then limited range of operation. Yes, I will show in the forthcoming slides what are the problems that are faced by transportation systems with electric vehicles. Particularly in Indian cases, we can analyze them, and these are the disadvantages of the green mobility system with the electric vehicles. That is, particularly with the battery types, that is recharging points, charging time, number of sheets, shorter battery life. All those things are the major contributors, right? Then safety is also another concern for a shared card method of transport, right? Then road infrastructure in these countries like India, Pakistan, Bangladesh, it is not possible to have a complete green mobility or green transportation system cannot be properly implemented in these three countries because of their infrastructure. Or the government has to contribute more on that. And then first source by which green mobility can be implemented is with the help of electric vehicles. In the transportation system, it is going to be with electric vehicles. So electric vehicles are alternate for IC engines. We know that IC engines two-stroke is completely eliminated because of less fuel efficiency. Then we come across with four-stroke engines. Four-stroke engines are contributing more for the pollution. Right. Not only that, fossil fuels are getting depleted, and by the year hardly for 200 years only fossil fuels will be available. So there is a ultimate need to go for alternate fuels. So alternate fuels based IC engines are to be developed or going to be the replacing the IC engines. The benefits of these electric vehicles include environmental benefits, lowering the carbon dioxide emission, performance benefits, including less maintenance, smooth operation, strong acceleration. These three are very, very important. Maintenance will be very, very less. Quiet and smooth operation is possible, and strong acceleration. We can also include deceleration. Even achieving 1 kilometer, 40-kilometer speed within 3 seconds or 4 seconds is also available with the help of electric vehicles. Right. Then major challenges what they face by the electric vehicle industries. Battery charging is the major problem. Right. The second parameter contributing for green mobility is pedestrians. So these are the points which we'll like to discuss about the pedestrians. That is, everyone should prefer to walk to school, to work, or to shopping. But particularly a common unique behavior against among the youngsters is even to go to the nearest shop. What they use is they try to have the to ride a motorbike, right? Ride a two wheeler and even maybe a scooty or maybe a small automated system. They want to go to the nearest grocery shop, which should be eliminated, because by walking it improves zero emission, that is assisting in environmental pollution. Then the second point is it is a good form of exercise for the body. So pedestrians, that is why the reason all developed countries are going for more pedestrian lanes than the automation lanes, right? So we should go with wherever possible, try to avoid two-wheeler systems, either go with the bicycles or please be as a pedestrian and reach that. So if possible, right? So this is second type of green mobility system. And the third type of green mobility system is bicycle, right? So bicycles are the great mode of green transportation. It is faster than walking. Yes, it takes 40 minutes to say, for example, 40 minutes to reach 3 kilometers means by walking. Then by cycling we can reach within 10 or 12 minutes we can reach that 40 3 kilometers, right? So that can happen. It is faster than walking, and it is low cost compared to the conventional IC engine based system. This is a low cost one, and it's a healthy exercise. Yes, bicycling, cycle riding is also a healthy exercise, and buying and maintenance cost is only fraction of that required by car, right? Even completely sophisticated car, bicycle, which is used by the cycle riders for international tournaments, is the maximum cost is around somewhere 3 to 7 lakhs, right? But when you look into a sophisticated car like a Jaguar, it costs more than 35 lakhs or 40 lakhs minimum. So it's almost a fraction, right? Even bicycles are available for 1,000 to 1,500 rupees. Standard bicycles are available, right? So compared to that, both their buying cost and the maintenance cost is very, very less, right? So we advise people to have more bicycle riding, which will assist with green transportation. And the last one is public transportation system. So almost all the government are looking into the development of public transportation system. The best example is Indian government has privatized the railway system, which was a government factor, is converted into privatization system, right? So that we can expect some good infrastructure could be developed. But in India, it has led into a failure, because once very recently, before the lockdown, because of the privatization, the destination has been completely went wrong. The privatized what is it? Railway system, railway train, railway traction system. What happened is, instead of reaching one destination, it has gone to the other side of the destination. So such kind of errors can also come across. So public transportation system would like to have good infrastructure, and it should be affordable and easily accessible more. Yes, it should be affordable by everyone, and it is useful for seniors and students who can attract to great discount. Yes, that's why passes are given for students, school going students, college going students, to at a subsidized rate government is planning. And also for senior citizens, like when people cross to more than 60 65 and above, are given subsidy in the rail networking system. So all these are to encourage public transportation, that is shared transport system. So by this, what happens is, instead of each and every going by one individual transportation system, when people start sharing the entire system, what happens is the cost will be reduced, the pollution effects will be reduced. So all these contributes for green mobility system. So the benefits of the green mobility includes less polluted environment, improved health. Yes, obviously, pedestrian system or bicycle system will improve the health of the citizens, and it leads for more sustainable economic development, including public and green vehicles transportation. creates more job opportunities. So that is what another important factor, because when electric vehicles comes into existence, the development of electrical engineers and electronics engineers will be more, opportunities will be given, and it reduces socio-economic inequalities. When you are using a public transportation system, irrespective of the religion, irrespective of the caste, everyone will have socio-economic inequalities that will be reduced, right? Not only that, the money savings, yes, if a person own a car and he drives some 40 kilometers, the cost will be 500 rupees per day. Whereas when the same fellow is using a public transportation system, his cost will be only somewhere around 27 to 50 rupees. So you can just compare it. Only one tenth of that particular value will be given, or only one fifth of that particular expense will be there when we go use a public transportation system or green mobility system. So in this way, it helps in money savings, that is less fuel consumption and also increased savings. So going in depth of the one part of green mobility system, the remaining three parts, it's very, very simple. That is pedestrians, already we have discussed. Uh, Bicycling also we have already discussed, and shared transportation system is also already discussed. But where opportunities are there for engineers is it comes in the field of electric vehicles. So in the forthcoming slides, we will see what is an electric vehicle system, what are the internal parts of the electric vehicle system, what the system is made of, what are the challenges, what are the design concepts, everything we will see, and also some existing solutions for everything, for all the challenges are also given here, right? So electric vehicle, it is propelled by electric motor powered by rechargeable batteries. Rechargeable batteries in the sense batteries charged by household mains, electricity, or powerful electric vehicle charging station. Right. Not only that, it can also be powered by supply utility, but we need a huge power conversion circuits when we are going with the power supply by utility. Right. So they convert the available power source from the source according to the requirement of the load. Either it will be AC to DC or DC to DC or DC to DC, AC to AC. Any means of conversion should be possible when we go with the electric vehicle system. So this is the evolution of electric vehicles. Initially, we have powered by, that is vehicles powered by bullock carts, then to IC engines, then to electric vehicles. Now combination, that is what we call as hybrid vehicles, and finally we come across plug-in electric vehicles. So the recent development in electric vehicles is plug-in electric vehicles. The block diagram of electric vehicle system is, this is what the block diagram. It has a energy storage or utility means, that is the driving factor, the energy driving factor, which is led as an input to the entire powertrain. Powertrain will have some drive control signals, that is start, stop, acceleration, deceleration. We call it as the braking system, all those things. So the energy from will be converted, will be from the energy storage device to the power converter. So this may be either a AC system or a DC system, but most probably it will be a DC system. So the power converter, what it will happen is, it will either convert into AC if the motor is AC motor, or if it is DC motor, it will boost the value of voltage, right? Voltage and current requirements that will be met with the power converter, and the power converter drives the electric motor. So the rotationary motion has to be converted into linear motion, which will be taking place with the help of transmission drive shaft, and finally the linear motion will be converted into rotational motion via the gauge system through the wheels. So this is what the entire electric vehicle system block diagram of the electric vehicle system. Right? So electric vehicles are powered by utility mains, that is electric locomotives. We have trolley buses and electric trams. As I said earlier, there are two means of powering the electric vehicles. One is by the battery powered vehicle, and another one is directly driving the power from the utility mains. So these transportation systems, that is electric locomotives, trolley systems. In Calcutta, we do have this tram systems. Then all these things are powered directly from the utility mains with the help of some pantograph collector. They will collect the current and they will drive it. Whereas coming to the battery powered vehicles, these are all applicable for passengers riding, that is electric bicycles, scooters, or individual systems. These are all individual systems. Even electric aircraft are also tested. Right? So this is what the electric vehicle system. So electric vehicles are powered by utility mains, that is electric locomotives, trolley systems, electric trams, electric buses, electric trolley buses, electric trams, electric buses, electric locomotives, electric trams, even electric aircraft also tested. These are the examples of electric vehicle systems. That is e-bike developed in the New York City, Spanish electric scooter, electric truck which is used in California. All these are the examples of electric vehicle systems. The other electric vehicle systems are electric bus with onboard battery, right? So onboard battery, they have a battery on the system itself. So whenever the battery goes down, we have some battery charging phenomenon for it. Either it will be a swapping technology or it will be a onboard with the help of some other charging stations facilities. We can do it. And this is the electric tram in Vienna. This is in India, Sadapti Express. This is electric aircraft. As I said, electric aircraft also tested in the year 2015. So coming to electromotive in India, the first electromotives are the traction systems, that is WAG goods train. What they do is they draw power from 25 kilowatt AC line. They have a traction transformer of two numbers per transformer substation with one in service, and the capacity is 110 bar to 25 kilovolt with the 21.6 MVA capacity of the transformer, and the frequency is 50 hertz. Power output of this particular locomotive is 5070 HP, and it is driven by a diode rectifier fed DC series motor. We all know that particularly electrical engineers may be knowing that DC series motors are widely used in traction systems because of their high starting torque capacity, right? So they are capable of starting with load, and they should be started with load, and they have high static torque capacity. So that's why we use DC series motors. So this is a 25 kilovolt AC line. So to drive this DC series motor, we need some power converter circuits which will be fed with diode rectifiers, right? So this is a block diagram of uncontrolled converter fed DC locomotive. That is 25 kilovolt line. There will be a pantograph collector to collect the current. So this is a circuit breaker. From here it will be going through the transformer locomotive with a tap changing transformer, and we have the diode rectifier circuit. So that should be driving the motors. So this series motor will be driven with the help of this uncontrolled converter circuit. So the developed another system is WEAG. These are all goods vehicle system. The capacity of the next developed goods vehicle system is 6280. Previously it was 5070. Now it is 6280, which also has 4500 amps, 780 watt DC converter cubicle with a smoothing reactor and transformer with primary voltage as 25 kilovolt and secondary voltage as and power as 6325. That is 6.3 megawatt power. The number of traction motors are six numbers inside this machine with 895 RPM and 6 pole with 780 volt, right? And the power rating of the motor is 785 kilowatt. This is WAG9. Further development is 6350 HP with the two power converters with the DC link voltage of 2800 volts. And this is driven with the help of induction motors. Previously, we have been using only DC motors, but after the development of induction motors, particularly screw gauge induction motors, which are robust in construction, right? So now we use induction motors for the traction systems, and we have a DC link voltage 2800 volt, and that DC will be converted into AC with the help of an inverter system with a 2.1 kV face to face with the motor frequency. Yes, you can see the motor frequency is marked from 0 to 160 hertz. Why? Because by changing the frequency, we can change the speed of the induction motor. Because basically, the synchronous speed is given by NS is equal to 120 F by P. So by varying the frequency, obviously the speed of the machine can be varied, right? So the traction motor used is 2.18 kilovolt machine with 370 amperes. 80 hertz is the normal operating frequency, and this is the power capacity, speed, and the Newton meter. That is the torque of the machine with the phase angle of power factor of 0.88, and three-phase induction motor was used, right? So nowadays, all the traction systems are using only induction motor systems, and nowhere we are using DC motors unless otherwise for the low-cost passenger meter gauge passenger system only uses DC systems, whereas the remaining all converted into AC system. Right? This is a block diagram of the inverter based, that is the induction motor driven system. You can see the same pantograph collector to collect the current from the main utility mains with the circuit breaker. And this is the transformer. It will be fed to the converter, and the converter will drive the inverter, which is going to drive the induction motor. These are the examples of electric trams. Electric trams are the vehicles which run on tramways along the public urban streets. Not like the railways. The railways are different from tramways. Tramways can be implemented for a very short distance in the public urban cities, and they use DC power supplied from overhead lines. Tramways mostly they won't use AC power. They use only DC power. The power is obtained from the trolley pole. This is the trolley pole from which the power is collected, or a current collector mounted on the roof of the tram. This is the roof of the tram. The power collector will be there. And the track rails, these are the return paths for the DC current. These are the incoming paths, these are the return paths. This is the streetcar electric tram system. This figure shows the EV trolley, electric vehicle trolley bus system, that draws power from the overhead lines. These buses draws power from overhead lines using spring-loaded trolley poles. These are the spring-loaded trolley poles, right? Two wires and poles are used to complete the electrical circuit. So two wires are used. This is different from tram. Tram uses only one wire and the return is through track, whereas this type of system uses two poles, two wires, right? The voltage by which they are used is 600 volt mostly used. This is trolley buses used in France and poles with springs and pneumatic poles, lowering cylinders. These cylinders are used to adjust. Suppose if the terrain is somewhat a lower terrain, right? So in that case, what happens is we can use the pneumatic poles and cylinders to adjust the height between the vehicle system and the poles. Right? Then electric bicycles, which we call it as e-bikes. They use electric motor used for propulsion, and almost these machines was only rechargeable batteries. The previous system are you directly taking the power from the utility mains. The forthcoming systems are using stored energy principle concepts. Right? These are classified into pedelec systems and power on demand systems. Pedelec system means the rider's pedaling is assisted by a small electric motor, whereas power on demand is motor is activated by throttle and using handlebars in the scooters. Right? This is electric truck. This electric truck is designed with the help of batteries. That is, it is not using a direct powered by utility. It was using the principle of stored energy principle. So batteries are used to deliver the cargo, right? And this is electric aircraft, so which uses a solar panel at the top. It has a solar impulse too. In 2016, this was designed. First solar powered aircraft to complete circumnavigation of the world. It has completely traveled across the world. It covered 42,000 kilometers by piloted fixed wing aircraft using only solar power. It used only solar power. And the aircraft was powered by electric motors, electricity supplied by the batteries, ground power cables, solar cells, ultra capacitors, and fuel cells. All these are the fuel sources for this particular electric aircraft. Then electric bus. So electric bus is one best example for the storage principle, storage electricity principle. It can store electricity on board. It uses rechargeable batteries or ultra capacitors, right? So, but the drawback is require frequent recharging than batteries. That is, when you use ultra capacitors, though they can deliver power at a higher rate compared to the batteries, but they require frequent charging than the batteries, and they are very efficient, right? But very efficient when the frequent stopping happens, right? Because battery capacitors can charge and discharge at very faster rate. So this principle was used of the ultra capacitors are used in the systems where we have frequent stoppings, suburban systems we call it as. We call them as suburban systems, or the similar systems like our electric trains available in Chennai city, the local trains of our Chennai city. Those things, though, suppose if we are designing a battery electric bus system with frequent stopping, then we can use a ultra capacity system. Whereas when we are planning for a battery system, battery bus system with the with too much of distance, say for example distance of a source and destination is 40 kilometers or 50 kilometers and above, we can go for rechargeable batteries. Suppose if the distance is 1 or 2 kilometers, we can go with ultra capacitors. These are the electric cars that are available commercially in the markets, that is Nissan Leaf and Tesla model. Tesla is the first company to come out with complete sophisticated electric cars. Then what is the schematic of the electric cars? This is a basic schematic of the electric car. It has a battery and it has a power converter to convert the battery power into the driving force, and also a charging cable. And there will be two motors, the front electric motor and the rear electric motor. And they use a regenerative braking principle, that is converting the energy into some other form and utilizing it. Right. So this is the first early electric car that was built by Thomas Parker. He is an English electrical engineer, inventor, and industrialist to patent and improve the lead acid batteries and dynamos. With the charging of the electric car, this is the currently available charging system. BMW i3 charging in the street. These systems are available across the street, like our fuel stations, charging stations are available in the US to charge on the streets. But why we should go for an electric vehicle? Air pollution and greenhouse gas emission are the two important elements which leads the path to electric vehicles. Not only that, in addition, we have the elimination, the depletion of the fossil fuels. So only these things are contributing major towards the electric vehicle phenomenon. So vehicle production stage adds to total life and life cycle environmental impact. Through the pollution, we can have extraction and processing of material resources, manufacturing, vehicle clearance stage, and fuel production. Additional sources, GHG, AP emission, greenhouse gases, and air pollution emissions also leads to electric vehicles. Then hybrid electric vehicles. Toyota Signature Class is the first hybrid vehicle developed. What does this hybrid vehicle means? So there's a broad classification of electric vehicles. Electric vehicles are broadly classified into hybrid electric vehicles and plug-in electric vehicles. In hybrid electric vehicles, we have series parallel and series parallel hybrid electric vehicles. Whereas in plug-in electric vehicles, we have plug-in electric vehicles and plug-in hybrid electric vehicles. That means an pure electric vehicle is one which is fueled only with the help of electricity. Whereas a hybrid system means it has both the combination of electricity and also the conventional IC engine combination. Hybrid means a combination. So these are the things, right? So plug-in electric vehicles, the battery electric vehicle, this is what the battery electric vehicle. We have a battery, we have a converter. That converter will drive the electric motor and the motor drives. Whereas fuel cell electric vehicle, there will be a fuel cell, that is a hydrogen cell or nitrogen cell, which will be converting the energy liberated and DC to AC, or the AC and the AC power will be driving the motor. These are the configurations of hybrid electric vehicles. That is series configuration, where F is the fuel tank, E is the internal combustion engine. As I said earlier, hybrid electric vehicle is the combination of both electric vehicle system and also the internal combustion engine system. So E is the internal combustion engine system, whereas M is the motor system, right? So what happens is the fuel will be driving the internal combustion engine system. That internal combustion engine system will drive the generator. So generator will generate AC power or the required DC power that will be fed to the power converter. The power converter will have two operations. One is it will make the battery to be charged, and another function is driving the motor. So this is what we call it as series hybrid, because everything is connected in series. The example of the series hybrid electric vehicle is Chevrolet Volt, Fisker Karma, and Renault Kangoo are the examples. Then parallel hybrid is fuel will be there and IC engine will be there, that will also drive power. Suppose if you want only for a smaller acceleratable distance, this entire IC engine principle will be working. After that, there will be a break in the system. So at the time, what happens is when the IC engine is driving, it drives the vehicle and also it charges the battery system. At the time, what happens is the power is bidirectional power, so the motor will act as a generator. Once when the battery is fully charged, this there will be a open switch over here. That switch will be open, putting this entire system into shutdown. Then what happens is battery will be the power from the battery will be converted will be fed to the power converter, and the power converter will drive the motor. So this here we are going to have bidirectional power. Both the motoring action will also be there, the generating action will also be there. The students who are the electrical people who are learning about the dice, who are learning about the four quadrant operation of the DC drives, they will have more insight towards the conversion of the power. Both the generating mode and the motoring mode will be given. So when it is in generating mode, the IC engine is operating, it will be in generating mode. When the IC engine is in shutdown process, it will be in motoring mode, driving the shaft of the engine. Honda's Insight, Civic Accord are the best examples for parallel hybrid systems. Then comes the series parallel, the combination of both series and parallel. This is what the example for it. Toyota Prius hybrid electric vehicle is the best example for the series parallel hybrid electric vehicle system. Right. Then we have complex hybrid electric vehicle system. The powertrain configuration, that is a hybrid, how the powertrain configuration happens. That is the front and rear tires will be there. In between them, we have what are the various sections, the crankshaft section, the machine on gear input, axle drive, all those things are shown in this block diagram. So plug-in electric vehicles are very, very common nowadays because they have a larger energy capacity and battery back, right? So the more energy does not increase the strength of the hybridization, and larger battery backups can be increased, tend to increase the maximum battery power available. That's the reason why people are going for plug-in electric vehicles. So another important advantage of plug-in electric vehicles is they ensure bidirectional power flow, right? Which leads to the principle called as a smart grid, that is V2G, vehicle to grid and vehicle to bus, V2 bus. Principles are derived from plug-in electric vehicle phenomena. These are the comparison of the configurations, that is series parallel, series parallel combination, driving cycles, that is it is limited. Series configuration has limited driving cycles, whereas this parallel will have high driving road infrastructure, right? Then coming to the weight, this is heavy weighted. This is relatively higher compared to the series. Obviously, this will be more weight. The reason is combination of both series and parallel, so it will be of more. Then capital cost, this will be of high cost, but this will be a slightly lower cost, right? And this will be of a very, very huge cost. Huge investment is needed. What are the PEVs available in the market? Chevrolet, what is the electric range configuration? So this will give you the insight of various plug-in electric vehicles available in the market. This model is available in India also. It has a solar panel roof, making the renewable energy principles to coming into existence. Then battery charging is done when the car is parked. That is one good, awesome future of electric vehicles. We can charge them. That is, for example, today morning, I'm starting from my home to my college. What I can do is I can charge my vehicle yesterday night, and I can make my vehicle to be ready. Today by 9 or 8 o'clock, I'm starting from my home. I'm reaching my college at 8:45. Then what I can do is certainly there will be a depletion of the charge, or the battery would have got discharged because it has been riding for 45 minutes. So what I can do is I can park it in my car parking station, and when that car parking station is made of a solar panel, with the help of the solar panel, I can directly charge my car system. Or if the car parking system is having a separate charging station, with the help of that charging station, I can charge my battery, right? So this is what the best example of the best property of electric vehicles, right? Then supplies powers to this. The particular feature of this Toyota car is the renewable energy grasp from the solar panel is used to power all the accessories like air conditioning, power window, interior lights, everything will be driven, and it is available in Europe and Japan. Now the system is also introduced in Indian markets also. So smart grids are completely assisting transportation system, because you can see plug-in hybrid electric vehicles are also a component of smart grids. So how they can these vehicles can contribute in smart grid is they can have convenience charging systems. Then we come across a principle called as TOU. TOU is time of use charging and smart charging. So to say more about this time of use, even at your home, right? What happens is you can see your load profile of your home. Load profile. What happens is, let us take early morning 6 o'clock. Early morning 6 o'clock. We will have a slight higher power demand. Say, for example, before 6 o'clock only, the fans would have been switched on. But at 6 o'clock in the morning, almost all the people at home tries to wake up. So what they do is, if the light in a sunlight is not available, they used to switch on the lights also. So fan will be running, light will be running, slightly increase in the load demand, right? This pattern may happen until 6:30 or 6:45. Then after that, what happens is the demand decreases. The lights will be switched off, but fans will be running, right? Suppose if it is a cold climate, the fan rods will also be switched off. At the time, if you switch on your pump motor, that is sump motor, what happens is you can calculate what is the time taken by the sump motor to fill your tank, right? So the time taken will be very less. Suppose instead of that, if you are switching on your sump motor at 10 o'clock, and when you see the time taken by the sump motor to fill the tank, it will be slightly higher when compared to switching it at early morning 6:30 to 7:30, right? Why such condition is happening means the demand increases when time goes on. When you see the load profile, the entire load profile of a power system, it increases from 8 o'clock till 12 o'clock or 1 o'clock in the afternoon, and there will be a dip. So when there is more demand at the time, when you use more energy, then your electricity building will be according to that pattern, which we call as time of use, right? So likewise, when we are using the plug-in electric vehicles, the two, with the help of smart grids, they contribute more for this timing of charge. That is, they will have bidirectional meters. That meters will indicate and make you create an awareness to your mobile phones, saying that now the electricity tariff is very, very less. So this is the right time for you to charge your electric vehicle. So such kind of awareness can be given to the consumer with the help of plug-in electric vehicles. This is a very big advantage of the smart grid system uh, and the installation of electric vehicles in the smart grid, or the utilization of electric vehicles in the smart grid system, right? This electric vehicle utilization in the smart grids is governed by two important factors. One is called as V2B, vehicle to bus, and another one is vehicle to grid. What is this vehicle to grid? Vehicle to grid is very, very important phenomenon, right? So what happens is, you are charging your vehicle, electric vehicle. Then what you do is, you are traveling to one, say your college. In your college, once again the battery has come down, so you are charging the vehicle. Say let us take 45 minutes to get it charged. Once the battery is fully charged, your vehicle is going to remain idle for 8 hours or 9 hours, as long as you are in the college. So at the time, what you do is, instead of making the vehicle to be remaining idle, the battery inside the vehicle can be connected to an inverter, right? So what happens is, the DC power will be converted into AC power, and that AC power can be used for, say, for 4 hours or 5 hours to drive some load. Such a phenomenon is called as vehicle to grid concept, right? Suppose if you are driving the nearby loads with the help of that battery, that is a local grid, whereas when you are feeding that entire AC power to the electricity grid, then we call it as complete V2G, vehicle to grid phenomenon. So this V2G phenomenon sounds good whenever we go for smart grid principles. So the power systems with the renewable energy generation is given by passive services and active services. The advantages of PEVs. Let me make it fast. I have to go with some more slide. So I may be skipping to slide. Please kind. I am apologize for it. Ancillary services. The ancillary services that are provided are active power control, reserve voltage support, compensation of active power losses, black start, system condition, optional measurements. Then what are the opportunities for available for the engineers? Means plug-in electric vehicles have more technical issues, that is issues pertaining to design, issues pertaining to the operation, and the policy-based issues. These are the various broad areas where we can do some research. Then in the design issues, they have optimization issues, how effectively energy can be, efficiency can be improved with the PHV train, reducing the capital cost, battery issues, modification, upgradation, design of smart meter, bidirectional communication network. And coming to the operation-wise issues, smart metering, grid interfacing, access to charging infrastructure, battery life cycle times, then testing and evaluation, safety issues, immigration, multi-charging networks, and billing systems. These are the examples. Coming to the policy-based issues, lack of government policies and standards has to be developed, standard protocols has to be developed, then optimal tariff pricing incentives, stakeholder motivation so that it encourages more people to come into that electric vehicle principles, then developing of universal codes, then consumer education, all these are the policy-based issues. The government, the Indian government policy is started in the year 2020 to reach almost by year 2025, everything should be electric vehicle. This is what the Indian government is planning. Then Mahindra has come out with the electric vehicles. These are all the electric vehicles developed by Mahindra. The other electric vehicles in India, these are the other electric vehicles, Tata Tigor, Tata Nano, then Speedway electric vehicles, Kinetic Green. Electric two-wheelers, we have too much of electric two-wheelers. Ampere is a scooter developed by a company from Coimbatore. This is one very good example. KSRT is the first road transport system apart from Ahmedabad to drive for a large distance. But what is the problem faced? This is a very big problem that is faced by KSRTC. On one fine morning, the Ernakulam to the bus driving from Trivandrum to Ernakulam was stuck because of running out of battery at the X-ray junction at Chetala. This was a very big problem. Because of this, almost what happened is more than 8 hours to 10 hours, the passengers were stuck in because of this vehicle. So the charging solutions in India, we have only this much charging solutions. That is battery swap technology. It is developed by Ashok Leyland. For every 40 kilometers, the battery has to be swapped. That is, this bus was developed by Ashok Leyland. So what they did is they swap the battery for every 40 kilometers. Once the bus runs for a 40 kilometers, there will be some mechanics available who will be swapping the battery, right? So the battery power, this is a completely air-conditioned vehicle, and it has a complete digital control with a zero emission bus. And this system also has a reverse camera, GPS, or the additional features, right? This YouTube video I will come across in the latter part. The feasible upcoming charging solutions are developed by ABB, where there are no overhead lines, ultra fast charging times at selected bus stops. New opportunities are also available, and it is very silent and flexible. Zero emissions urban bus transportation system, it helps. These two examples also you will see. So now let us look into the videos with the charging solutions in India and abroad. You can see two videos. Audience, can you please say whether whether the YouTube video is visible. Is the YouTube video visible? Okay. So this is one example, and the other example, what I can show is, so this was the example of battery swapping technology that happened in India, but the other one will be quite interesting. You can see this example may be somewhat interesting more. Is it visible now? Audience, please kindly text it whether YouTube video is visible. Okay, thanks. Thank you. So you can see a wonderful system
Sir.
instead of battery swapping technology. Let me explain what is it. In India, we have been using battery swapping technology, but that is more time consuming and that is not a feasible solution. Now, these people they have come out with a flash charging system which can charge an electric bus with only 15 seconds. Worry about it. So ABB is one of the company which developed it, and whenever you have any technology developed, certainly there will be some competitors. So the competitor for ABB who developed it is another people also they came out with some such kind of technology. So, this is what I would like to address on the topic of green mobility. So, if there is any questions from the audience side, you can text it in the chat box. Any questions from the audience side? Sir? Balaji sir? Possible measures to be taken in transportation, especially during this COVID scenario and rising fuel prices. Yes, the simple way is because of the lockdown to avoid COVID issue, let us stay home, stay safe. That is the most basic phenomenon which we can do. Then coming to rising fuel prices, better go for shared transportation system, right? And unless otherwise reflected, please don't come out or else stay home. That is what we would like to suggest. Right? Kirti Narayan sir, yeah, I think this is the way that I can answer as of now. Right? And a lot of automations are being happening in the transportation system, such that even with the app we can just open and close the doors, as I said in the first part of the presentation, on demand car services, no, at the time. So like that, without touching the cars doors, and where the door handle will be handled by every person, even a person affected with the COVID, with the help of by touching the handle, chances of getting COVID transferred from one person to another person, right? So such things can be avoided, right? So is there any other questions? Balaji sir? Balaji sir, if there is no more questions, can we wind up? So I think there is no more questions. So thank you for the Department of EE and ECE from RVS College of Engineering and Technology for giving me the opportunity to present on the topic. Thank you, my dear friend Dr. Sundar Prakash Balaji, for the opportunity, and also the participants for the passion listening on the concepts of green mobility. Thank you all.